So let's maybe consider the Earth going around the Sun, and it's got a certain mass, which I'm going to call little m, and also we have the mass of the Sun, which I'm going to call big M. They're separated by a distance from their centre of masses of r, and this is going at some point with a tangential velocity of v. But what we know is that from Newton's law of gravitation, the force between these two objects is going to be equal to gmm over r squared. Okay, but we also know that the force on this thing here, causing it to move in this circular path, and we're going to assume a perfectly circular orbit at the moment, this force, the centripetal force, is equal to mv squared over r. And effectively, it's this gravitational force here that provides the centripetal force. So what we can then do is equate the two together to say that gmm over r squared is equal to mv squared over r. And what you can see now is that, first of all, the mass of the Earth is basically cancelled off both sides, and we can also cancel the r down here. So what we can then say is that gm over r is equal to v squared. But what do we know about the velocity of this? Well, so far there's no t and so on, and we don't even have an r cubed. But what we know is that the velocity of the Earth is going to be equal to its circumference, the distance it travels in 1 year. And the circumference of this is going to be equal to 2 pi r, and the time it takes to go this one rotation around the Earth is equal to 1 Earth year. We can then say, if we square both sides of this, we can say that v squared is equal to 2 squared, which is 4, times pi squared r squared over t squared, and we can then substitute this back into here to replace the v term. So what we can then say is that gm over r is equal to 4 pi squared r squared over t squared. And if we rearrange this to make t the subject, so what I'm going to do is I'm going to bring this up here to say t squared is equal to 4 pi squared over gm multiplied by r squared times r, which is r cubed. And what we can see now is that provided we have maybe the same gravitational constant, which we must do, we've got the same mass of the Earth, and then 4 pi squared as well, everything here inside these brackets is a constant. And that means we can say then that t squared is proportional to r cubed. And it's only really, this is basically what Kepler found out, and it's only really later that this is what Kepler found out that then allowed Newton to look at his universal law of gravitation.